Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. Now, in today's video, I want us to look at multiple choice questions now under the topic of vertical projectile motion. All right, without wasting any further time, let's dive into it. Okay, so number 18, they tell us a ball is projected vertically upwards. Okay, the way to project it means it has a initial velocity. Okay, initial velocity is not equal to 0 because remember from the definition of projectile means it is an object that has been given an initial velocity. Okay, yes, vertically upwards from the ground. Okay, it returns to the ground, so it returns to the ground. Okay, from the ground, and it returns to the ground, makes an elastic collision, meaning now there is no contact time. Elastic collision means now no contact time. Contact time, meaning now immediately when it reached the ground, it went back to the very same position, because if it is an elastic collision, it is a collision where no energy was lost. So if it reached the ground with a velocity of 5, it will go up with the same velocity because now there was no change in velocity or any kinetic energy lost or whatever energy lost with the ground, and then bounces back to a maximum height. Very, very interesting. Ignore the effect of whatever. Which one of the following velocity time graph represents the motion of the ball? Check. We are told that the ball was projected upwards from the ground. Okay, was projected upwards from the ground, and it went to the maximum height. Then it returned back to that particular person who projected it. Right. Then now, when it reached the ground, with, let's say it went with the velocity of v, then it will return back with the velocity of negative v, but it will go up immediately with the same velocity of v here, and it will go back to the same maximum height. Why? Because now there was no velocity lost, so the velocity is still the same. So it means now it will return to the very same maximum height. And also check the velocity here when it was projected initially and the velocity when it now went to the maximum height for the second time, they are equal. So now let's look at that. Here, can we see now, okay, a graph that I might expect it is something like, okay, if this is V and this is negative V, I'm told it was projected. It means it started with a certain velocity. It went to the maximum height for the first time. It went to, after going to the maximum height, it returned back home, so returning down to the ground with the same velocity here. Then this is now telling us, or it is during the collision here, okay, during the collision of the ball as well as the the ground again. Therefore, can you see, they told us the collision was elastic, so therefore there was no time between the surface as well as the ball. If there was an inelastic collision, it was going to be like this, meaning now there is time in which now the ball stayed a little bit. But now, since when it is elastic like that, it means now it is like that. Then it will return to that velocity and then go to the maximum height like that. Like that. So now I want you to check something. Here the velocities are equal. Okay, so I'm expecting a graph of some sort. So when I check here, A is the most correct answer. Why not B? Why not B? Because now, can you check the velocity that it started with here? It is not equal. And also the velocity here, or rather the distance from when it was projected to when it reached the ground, it is not equal. And can you see? But it's supposed to be equal because now it traveled the same length. This one, why is it wrong? It's wrong because, okay, it's fine now. The collision occurred now. Okay, can you see it went from the ground to returning to the ground again? This is right, okay? But now, since well the collision it is inelastic, it's supposed to return back to the same velocity thereof. Then like that. But here, can you see it is a little bit shorter? So this is wrong. Here, it's also wrong. Most correct answer it is A. An object falls freely in a vacuum. Okay, it falls freely in a vacuum near the surface of the earth. Okay, which one of the following statement regarding the motion of the object is correct? Okay, so it falls freely, so it tells us it is in free fall. Okay. So what happens in free fall? The velocity of the object remains constant. This is a lie. Remember, as the object goes down, the velocity increases. As it goes up, the velocity decreases. The velocity of the object will decrease uniformly. An object falls freely. Falls. No way. No way now it is gonna decrease. Remember the analogy of window from the video that I explained in the vertical projectile motion. Window says now velocity increases as you go down. So now this is not correct because now the velocity of object as it goes down will decrease, will increase uniformly. The rate of change of velocity will increase uniformly, not the rate, the velocity. Oh, okay. The rate will be equal. Why? The rate will be equal because it will be decreasing with the same velocity. Meaning, if it decreased with 36, it will maybe decrease with 30, then 24, like that. So the velocity increases uniformly. Okay, velocity increases uniformly, but the rate of change in velocity is constant because now it is changing at a constant velocity. So the velocity increases uniformly with the same value, but the change in v it is constant. So now the rate of change of velocity will increase uniformly, not the rate. The rate of change of velocity of the object will remain constant. Very, very good. Can you check? I want you to understand that the rate, it changes with the same rate now. If now it changes now, let's say it started with 2, then 6, then 15, then 29. This is now what we mean the rate of velocity. The rate of change of velocity increases again uniformly. But now, since while it is 2, 4, 6, 8, 10, the velocity increases uniformly, but the rate is equal. The rate in which it is changing, it is by 2. It is equal. The rate, can you see that? Yes. Then, Haibo. Okay. Then number 20, a stone is projected vertically upwards from the top of the building, from the top of a building at a speed of v, okay, is projected from, so a stone is projected vertically upwards from the top of the building. Okay, so let me try to draw a scenario. Here is our ball projected upwards from the top of the building. Okay, at a speed of v meters per second. Okay, then the position type graph below represents the motion of the entire stone. Okay, that what I've drawn already. Now the question is, which one of the following combination below regarding the magnitude of the stone's velocity and acceleration at time t1 is correct? Let's check what is happening in time t1. At time t1, what is happening? This is the maximum height. And what is happening at the maximum height? The velocity is equal to 0, but the acceleration it is equal to what? Magnitude of acceleration, it is 9.8 meters per second. The magnitude of acceleration does not change. Whether you are at the maximum height or anywhere, it is always 9.8. It does not change. Okay, what will change is the velocity. So let's look at the correct answers. The magnitude, we want 0 and 9.8. Where is that? The answer, it is A. I hope you understand that. A small stone is dropped from a height y above the ground. It strikes the ground after time t, as shown in the diagram below. Okay, take upwards as positive, as the positive direction. Okay, and take the ground as the reference as zero reference. Okay, ignore the effect of air resistance. Which one of the following represent the which one of the following diagram shows a correct position time graph for the motion of the stone? Now, the stone, let's say here is the height, and it was projected, it was dropped. Okay, so when it is dropped now, it will start from the velocity is 0 because it is dropped, right? Then it will go down like that. Therefore, they tell us that you should take upwards as positive. If I take upwards as positive and I try to draw that graph, I'll say, okay, my graph should look like this. Because now, if I'm taking upwards as positive, it means now this ball, it is displaced in the negative direction. Why? The displacement here should be negative. Why? Because I chose upwards as positive, and my ball, it is going down. So can you see the change in y will oppose the direction? So it means it should start at 0. Okay. should start at 0 and maybe do something like that. Okay, maybe. This is what I expect the graph to be there of. Okay, yes. Let's see the options. Oh, they also told me that take the ground as a reference. So it means it will end at the ground. So it means it should end at the ground. So it started at that particular height, then it ended at the ground like this. This is 0. Okay, so I'm expecting a graph like this. Okay, yes. Remember, I cannot draw a graph like this or a straight line like this. A straight line like this, it is a velocity time graph. So this one, it is incorrect because can you see it is a velocity time graph? This one, it does not do like that. There is no shape like that. It always follows the trajectory. Then this one is the acceleration time graph. Then now C is the most correct answer thereof. This was easy to It was easy to eliminate y because now, can you see now, you should know the type of graph. Changing y, the graph, I think it is parabolic. Okay, can you see? Not this parabolic like that. No. If it was parabolic, it's either it is like this or it is like that, not a shape like that. Therefore, the diagram below shows a section of the path of a stone projected vertically upwards. Very, very interesting. Here it is the maximum height. I know velocity it is 0. Okay. Here, let's say it is v. Here, the velocity will be greater. Let me say v1, v2. The velocity of 3 will be greater than the velocity of 1, the magnitude. Okay, because now it was going to be equal here, the magnitude. Okay, but now can you see it has went further downwards, so it will be greater. Then this one will be the greatest. Okay, velocity here, it is at maximum. Why? Because now as it goes down, as you go down, the velocity increases. Okay, so it will reach the ground with the maximum velocity. And remember always the analogy of window. It says now velocity increases as you move down. Velocity increases as you move down, like that. So the question is, which one of the following, or at which position of the, at which one of the following positions indicated on the diagram will the magnitude of the momentum of the stone be the greatest? Remember, the momentum will depend on what? On mass. And actually, the momentum depends on velocity. So, provided that the mass is constant, we want where the velocity is at the greatest, the magnitude. It is where it is the velocity of IV. So it means at IV here we have the maximum velocity. So we will have the greatest momentum. So the correct most answer there, it is at IV. Number D. 23. As the object is projected vertically upwards, ignore a resistance. As the object rises, its velocity decreases. Remember, I said as it goes up, the velocity decreases because it will reach 0 meters per second. But if it goes down, if it goes, I'm not sure what's happening to my English. It feels like I'm losing concentration or whatever. But yeah, as you go up, the velocity decreases because it will eventually reach 0. But as you go down, the velocity will do what? As you go down, the velocity will increase. Remember, if you know window analogy, this will be very, very interesting. So let's look at the options there. Its velocity and acceleration are both directed upwards. Okay, velocity, when it is projected upwards, the velocity, okay, let me say the velocity decrease and velocity increase. Yes, the velocity will be upwards because it is projected upwards, right? The velocity will be upwards. But now, remember acceleration. Acceleration always acts downwards. So this one cannot be the option because now it is upwards, both of them upwards, right? Then, okay, let me try to understand that. Number 20. Okay, no way that our velocity will be downwards. And another thing happened, our velocity here, its velocity is directed downwards. Okay, this one is very, very interesting. Now, I want us to see something. Let me reread this question. An object is projected vertically upwards. Okay, as the object rises, its velocity, okay, its velocity is directed, its velocity will go down. I don't understand this. Okay, one thing for sure, if both are upwards, with both upwards, no, it is wrong. And now let's look at number C. It is directed upwards, but its acceleration is directed downwards. Okay, this one is an option. The acceleration downwards, no. Now let's look at number B as well as number C. Its velocity and acceleration are both directed downwards. Okay, its velocity. Its velocity, it is directed upwards or downwards. I think it's gonna be both of them are directed. The velocity is directed upwards. Why? Because now as it moves up, now the velocity decreases. So it means now the change in velocity, it is negative. Okay, so it means the change in velocity, it is directed downwards, now causing a decrease in velocity. So now I want to believe now the most correct answer it is B. The velocity and acceleration are both directed downwards. Why? Because now if the velocity was not directed downwards, it was going to have an increase in velocity. The velocity was going to increase or remain constant. But now, since well, its velocity is directed downwards, even though it is projected up, it's going to cause the decrease in velocity. So the most correct answer is B, the off. Okay. The most correct answer it is B for number 23. Number 24, a ball is projected. So, okay, a ball is projected vertically upwards. A ball projected vertically upwards. It means now I have an initial velocity. Okay, you know. Ignore air resistance. Which one of the following statement about acceleration of the ball at its maximum height is correct? Now, remember, I always tell you that acceleration, it is equal to G, the value of G, and it is always down. Okay, so now, where at the maximum height, what the examiner always catches you because you know at the maximum velocity, the maximum height velocity is 0, but acceleration is always 9.8 acting down. So the most correct answer here it is now 0, no. G directed upwards, no. G is directed G and it's directed downwards. Very, very interesting. G and is directed horizontally. No, we are moving up or down, not left or right. B is the most correct answer thereof. Number 25. Number 25. The graph below shows how one of the physical quantities associated with an object is in free fall changes with time. The label of the y-axis is omitted. Include ignore a friction. So we know this graph like this is always an acceleration graph. Acceleration graph, it is always like this. Let's check. Which one of the following physical quantity can be labeled on the y-axis? Not velocity, not position, not momentum, but maybe weight. Okay, yes. Okay, remember this is acceleration time graph. Okay. Most correct answer therefore it is C. Which one? Oh, so two balls of masses m and 2m are dropped. Okay, simultaneously. Simultaneously, we have m and 2m being dropped simultaneously, okay, at the same time. And now both their velocities are 0 when they are dropped, okay, from the same height, okay, the height here is the same, height h, above the ground. Ignore air resistance. When the ball strikes the ground, which one of the following physical quantities will be the same for both graphs? Now you should think very, very carefully about that. You should think very, very carefully about that. Now the question is, which one of the physical quantities will be the same for both of them? Okay, first thing first, we should eliminate mass. Let us be in a position of weight. Why? Because now their mass is not the same. Remember, weight, it is mg. So if their mass is not the same, there is no way. Okay? Another thing that we can eliminate now, it is momentum. Momentum, no, their mass is not the same. Okay? The mass is not the same. Velocity, let's talk about the velocity. Remember now, it was dropped, okay? It was dropped like that. So if it was dropped like that, both of them, the velocity from here, remember it will be, they are both moving under the influence of negative, or rather they are moving under the influence of what? Of gravity. So it means now the velocity will decrease or will increase going downward according to the constant g like that. So it means now the velocity here will be the same for both of them, okay? The velocity will be the same for both of them, irrespective of which one reaches the ground first. Okay, but now at the instant they reach the ground, their velocity will be the same. Why? Because now they are moving under gravity. So gravity is the one that gives them what? That gives them velocity. So can you say, and the gravity acting on them is the same. So now I want to believe now B is the most correct answer thereof. Kinetic energy, no, cannot be kinetic energy. Why? Everything that includes mass, it is wrong because their mass is not the same. So velocity, it makes it the most correct answer thereof. Number 27, a ball is dropped from a small height above the ground. Ignore resistance. They like to drop, man. The following pairs show physical quantities associated with the ball while it is in free fall, okay? While it is falling to the ground, or while it is falling to the ground. Now, while it is falling to the ground, what we know is that G, it is constant, V increases. So anything that has V will increase. Uh, Another thing happen. Let me see. Another thing. Yeah, yeah, yeah. That height will change. Height decreases because you move from a height there going downward. So it means height will decrease. So let's see which one of the which one of these pairs will both quantities change. Quantities change while the ball is falling. Okay. Okay, yes. So now let's look at this one. A, mechanical energy and weight. Weight, no. Weight, no. Weight, no. And mechanical energy, it is conserved. Remember the mechanical energy in an isolated system. This system is isolated. Why? Because there is no friction. And now the mechanical energy cannot change. So it means now the mechanical energy, it is conserved. Momentum, kinetic energy, okay, this will change because now the velocity changes. Momentum, it will change because now the velocity changes. So now this makes it the most correct answer if I look at it for now. Gravitational acceleration, no, this is incorrect. This is incorrect. Okay, incorrect. Gravitational acceleration, it is incorrect. Okay, then kinetic energy, yes, kinetic energy is true, but it is already incorrect. Incorrect. B, I'll come back to it. G, gravitational potential energy. Yes, this one it is correct. Why? Because now the height, as you move from this height going down, the height changes. So it means now mgh will change because height is changing. Okay. So yes, gravitational force. No, gravitational force will not change. So now the most correct answer it is number B. Consider consider the motion of a small stone thrown vertically upwards, okay, until it reaches its maximum height, okay, very, very good. Ignore the effect of friction. Which one of the following combination of the graphs correctly shows how the momentum P and gravitational potential energy changes of the stone change with time? Now let's talk about, before we look at the graphs, let's talk. It moves from vertically upwards, thrown. Okay, let's say here it is the ball, it is thrown until it reaches max height. What do we know about max height? We know velocity is zero. Here we know we had a velocity, okay? Now gravitational potential energy. My gravitational potential energy, which is mgh, will increase because now here initially the height is zero. Then there the height, it is whatever, h max. Okay, this is the maximum height. So here, stone change with time. So as it goes up now, my mgh will increase. Let me write it here. As I go up, my mgh will increase. But now what will happen to the momentum? My momentum P, which is mv, u is equal to mgh, and p is equal to mv. My momentum will decrease now because why? Because now my velocity is decreasing as I go up. So let's be in a position of selecting the graphs. A, P decreases. Very, very interesting. P increases. Okay, let's look at that. P increases. Sorry, P decreases, okay? Momentum decreases, but now can you see it is not decreasing gradually? It is decreasing a gradual or whatever in a curved surface. But now we know that what will happen, the velocity changes with the same rate. Okay, the velocity changes with the same value. If here it was 50, maybe here it is 40, 30, 20, 10 up to 0. So it means I'm expecting my momentum to change constantly like that. So this is wrong. Potential energy. My potential energy can change in however, I don't know. I'm not sure about that graph. But this one, it is incorrect. Very, very incorrect. Why? Because now my momentum, there's no way it's gone. But yeah, the height, we are not sure if the height is increasing with the same. So this one is the correct one for the height. Okay, the height, can you see it also follows the trajectory like that? So this one is correct, but it makes A incorrect. Let's look at B. B, this one is correct. It decreases now constantly, okay? But now U, the height does not change, like maybe it changes from 0 to 1 to 2 to 3. No, the height changes in that trajectory like that. So this is incorrect, making B incorrect. C, they are no, then it does not decrease like this. No, 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 no. Can you see my graph? It is like this when I draw there. Remember, we draw it a parabolic shape like that. Okay, so it should increase like that. This is my potential energy. So this is also wrong. C is wrong. Let's look at D. D now decreases gradually. Very, very incorrect. So it's in a straight line. Very interesting. Then U increases like that. Yes, very, very interesting. So the most correct answer is D. I want you to understand, once I say it moves from the ground or it is projected upwards, remember we draw the trajectory like this. We do not draw it like this. Okay? So it's gonna increase like that. Can you see now? The height is not increasing with the same rate here. So the graph should be like this, because here it is max height H max, okay, here it is H is equal to 0, the ground. So hence I want it to increase in this manner thereof. Whereas now the velocity it decreases with the same rate because it is only under the influence of gravity. So D, it is the most correct answer. 29. On 29, I'm not sure if they already given us an answer or what, but let's check. A ball is projected vertically upwards from the ground. Vertically upwards from the ground, okay, from the ground, and reaches its maximum height after a while. Very, very good. Ignore the effect of air friction. How will the acceleration and the total mechanical energy? Remember, total mechanical energy is conserved because why? It is an isolated system. There's no friction, there's no what. And also, oh, how will the acceleration and total mechanical energy of the ball at its maximum height compared to that immediately after it was projected? Okay, so they want to know, okay, how will acceleration be? Let's say Akiri, it was projected upwards. We want to know how is acceleration here, how is acceleration here. We know acceleration is equal to g and it is acting downwards. Here also it is equal to g and it is acting downwards. So it means now the acceleration should be constant, equal to. The acceleration is the same, so there is no change. Okay. Now, mechanical energy. What is happening to mechanical energy? Mechanical energy, it is conserved. Why? Because this is an isolated system. Okay. Remember why? Here at the bottom, we have what? Half mv squared. Okay. We have kinetic energy. Let me say, at the bottom, we have what? Kinetic energy initially, because now it is given an initial velocity, it is projected. But now, can you see now the height? mgh, it is 0. mgh, it is 0. Why? Because here there is no height. It is at 0, height 0. Okay. Therefore, it is as it goes up, what is happening? The kinetic energy decreases, and because here the kinetic energy, it is, let me say, u, here it is 0. The kinetic energy here at the maximum it is 0. Why? Because we know at the maximum height velocity it is 0 again. Therefore, but now I have what? Plus u final, like that. So if we have mechanical energy at the bottom is equal to mechanical energy at the top, can you see now here I have what? Only kinetic energy. It is equal to potential energy final. So now mechanical energy is conserved, meaning this kinetic energy, as I go up, it is being transferred to potential energy. If I go back down, this potential energy will be transferred to kinetic energy. So now the most correct answer it is A, equal to. So it means they have already given us an answer there. Number 30, a ball is dropped from rest. From rest. Okay, the weight dropped automatically tells us at a height above a concrete floor. Okay, at a height is dropped. That is the trajectory for dropped. The ball strikes the floor and bounces vertically up and down at the same spot. On the same spot. Okay, and bounces vertically up and down. Bounces vertically up and down. Like that, on the same spot. So this is what they mean. Now here, velocity is 0. Here, velocity is whatever. Remember, as it goes down, the velocity increases. So here it is Vmax. Okay, but as it goes up, the velocity will not be the same. V will be less than Vmax. Why? Because they did not tell us if it is elastic or inelastic. If it is there, if they have not told us that it is elastic or inelastic, we assume that the collision was inelastic and it lost its velocity. And if it loses its velocity, it will not return to the very same height that it was dropped from. So it will come here. Here it is 0. Here, this velocity here, let me call it velocity 1. It will equal to the velocity here, velocity 2. So now let's look. The velocity as we go down, it increases again. Then this is the collision between the floor and the ball. Then it happens, it goes. Now, can you see? After that, it came here. So they chose downwards as positive. So if they chose downwards as positive, it means the velocity when it reaches here, it will be positive. Why? Because now we chose downwards as positive and it is going down. Then when it goes up, its velocity should be negative. So can you see here? The velocity is negative because it is moving in an opposite direction. Therefore, it will reach the maximum height, this. Then it will go back wherever they're off. Then it will bounce again. I want to believe. So let's hear what exactly they're saying to us. At which time does the ball reach its maximum height after the first upwards bounce? Let's check. Here it is from the height. Therefore, it goes up. Again, therefore here it goes down. I mean, the velocity they are saying the velocity increases because why? As it goes down, the velocity increases. Therefore, here it tells you it is at the ground. Therefore, it will go up. Okay, this is at the ground here. Okay, this is what I've drawn here. It is at the ground. Then after that, it will go up like that. So here it reaches the maximum height. This is the max height on first trial. Then it will go downwards again. Therefore, after that, it will reach the maximum height. So here it reaches the maximum height on the second trial. So which one? They say after the first upwards bounce. After. Can you see after the first upwards bounce? So this is gonna be QY because now the first upward bounce was here. Okay, was here. This is a bounce, then it goes up like that. It reaches the maximum height. The answer it is B. Last one, a ball is projected vertically upwards from the top of the building point P, Q, R, and what. Now I want you to tell you something. Here, the velocity here, this is 0. Whatever the velocity is here, at R it is negative V. The same magnitude because it is returning to the same position, but in opposite direction. Here we'll have what? Negative V, V max. This is the maximum velocity. So they are asking us, between which 2 points will the ball undergo the greatest change in kinetic energy? The change in kinetic energy meaning now Remember, kinetic energy is half mv squared. So basically they're asking us, when is the ball gonna experience a greater change in velocity? So from here to here, the velocity, okay, it is small, but can you see from P to Q, the velocity change is small. P to Q, it is small. From Q to R, it is also small. But can you see from Q to direct straight to S? Now the change from Q to S, it is greater. Why? Because now, can you see the velocity was 0, but here the velocity is V max. So now there was a greater change in what? In velocity, meaning leading to a greater change in what? In kinetic energy. So we're going to say from Q to S. Is there an option like that? D is there, that option. So the most correct answer it is D. So thank you very much, folks. That's all from me for vertical projectile motion multiple choice questions. Let's meet again on the next video. Thank you very much.